Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can use properties of logarithms to expand logarithmic expressions. Now, with that being said, these are not the full list of every property of logarithms, but this is actually a select few that involve the fact that the logarithm of any base evaluated at 1 is 0. The logarithm of any base evaluated at the value of its base will be 1. And then we also talked about the properties of the product, the quotient, and the power when it comes to logarithms. So we're going to use just these 5 properties here in order to evaluate and expand out some of these expressions. Now you are going to notice that at times I am going to actually expand it. So if we have a value that can be evaluated, for example, log base 2 of 4, I am going to write that as 2 so that we can see it in its truly expanded and simplified form. So let's take a look here at this first one just to start. So we want to expand this logarithm using some properties. Well, right here immediately I see that I have the quotient property because I have an x and a y. I also see that I need to use my power property. So I'm going to start by using my quotient property. So this is the same as log of x plus log of y squared. Now that is the quotient property, so we've already separated it. Now the only other piece I want to use is my power property, in which case I get rid of this y to the power of 2. So all the way expanded here, we would have log of x plus a 2 log of y. And the reason why we have that 2 is because by that power property, our exponent comes to the front. And this would be our expanded form there. So you can see that we use both the product and we used the power property in order to expand this. And you can use them in whichever order you would like. I typically like to use my product or quotient property first and then apply my power property later. So let's take a look at a couple more examples here. So in this case, we're dealing with our natural log, and we've got some multiplication and we have some exponents here. So as we go to write this, we've got the natural log of h squared plus the natural log of j to the power of 11 plus the natural log of k to the power of -5. Now we can see that we have all of those. Each of them have a power. So in addition to our quotient or our product property here, we also want to use our power property. So in this case, we actually end up getting 2 times the natural log of h plus 11 times the natural log of j minus 5 times the natural log of k. Now the interesting thing here is if I were to go to condense it, typically rather than writing our exponent as a -5, we would condense that and actually turn that into a quotient as well. So it's interesting how those kind of play a role there. Let's take a look at 2 more examples where we're expanding our logarithms using our properties. Now in this case, we have the log of the cubed root of x y squared. Now anytime I see a root in a logarithmic expression, I want to rewrite my root as a rational exponent. The reason why is because we know the power property. We don't know any properties about radicals, but we know that my radicals or my roots can be written as rational exponents. Therefore, we can use our product or a power property. So this is really the same thing as the log of xy squared to the power of 1/3. Well, I'm going to start by using my power property because that 1/3 is applied to that entire product there. So this is really the same thing as 1/3 times the log of xy squared. Now our xy squared there, that is an example of a product property option. So we've got our 1/3 times the log of x plus 1/3 times the log of y squared. Notice how our 1/3 gets applied to both there because it's being multiplied by that log. Now the very last thing I want to do is use my power property one more time to get rid of this power of 2 here. And so we end up getting a 1/3 times the log of x plus 2 times 1/3 or 2/3 log of y. Now we could have gotten this another way by distributing our 1/3 at the beginning. And so we would have seen something like log of x to the 1/3, y to the 2/3. And then as we had that, we would come and it would end up being rewritten here. So it totally depends on how you would like to do it, but both options there work. Now let's take a look at one last example of us expanding a logarithm using properties here. So in this case, I see a power and I also see a quotient. So we're going to use both. Now, because I see a power applied to the entire quotient or the entire piece that I'm evaluating, I'm going to start with my power property. So that means I'm going to have a 3 times the natural log of x plus 2 over x minus 2. Now, our quotient property here tells us that those are going to get divided there. And when we divide logarithms, really what we're doing is we're subtracting them. So let's take a look at what that'll look like here. I've got 3 times the natural log of the top, which is x plus 2, minus 3 times the natural log of the bottom, x minus 2. Now, we've only talked about a quotient, a product, and a power property. We have not talked about any properties related to the sum or difference. Therefore, this is actually as expanded as this is going to get here. We can't change that x plus 2 or that x minus 2, so we are going to leave it in this expanded form. Now, that is how you can expand those using our 5 different properties. Again, we've talked about the product property, the quotient property, the power property, and the fact that the log of any base when evaluated at 1 is always 0, and the log of any base evaluated at that base itself will always be 1. So using those properties, we can expand logarithms. Please check out the next video in which we will be given an expanded logarithm and we are going to practice condensing it.